morning everyone. So let us start our class. So one question was left, and with that our chapter 6 will be completed. So let us do the last question, that is question number 6. Draw the diagram at first. So two triangles are there, okay, in the diagram. One is this triangle straight and one is this slanting triangle, okay. So two triangles are there, and you see here some marking is given, right, that this and this, like that. It means what? That this angle is equal to this angle, or you can say that this angle is bisected, okay. This dash means what? That they are equal, okay. Again you see over here also there are two dashes, okay, meaning same thing, they are also equal. Since there is one dash, so over there is two dash, okay. So there is nothing that two dash means different, one dash means different, nothing like that. Dash, if it is given, that means there is two dash, there is also two dash. So these two angles are equal and these two angles are equal. Means what? That this angle is also bisected and this angle is also what? Bisected, okay. Next over here it is point R, and over here it is point S, over here it is P, and over here it is T. Okay, so now you read the question. In the figure, okay, the side QR of triangle PQR, the side QR of the triangle PQR is produced to a point S. So this is produced to a point S, or you can say extended to a point S. And whenever if a side of a triangle it is produced or it is extended, then what will form? External angle will form, okay. So definitely we will have to use what? External angle property in this question. If the bisectors of angle PQR, so already we can say by the diagram only that this angle is bisected. If the bisector of angle PQR, and this one also it will be there, and angle PRS, so say this is also bisected. So if the bisector of angle PQR and PRS, so this is the bisector and this is the bisector, meet at point T. Say this is the bisector of this angle and this is the bisector of this angle. So this meet at what? At point T. Then prove that angle QTR, this angle is equal to half of angle QPR, this angle, okay. So let us first write the given part. Question number 6, solution given. So this is given that they are equal. This is bisected, that means this angle is equal to this angle. Bisected means what? Equal portions, isn't it? Divided into two equal portions. This is also bisected, that means these two angles are equal. So given, we will write that this angle is equal to this angle, that is angle PQT. Angle PQT is equal to angle, this one, TQR, okay. And one more, these two angles are equal, so angle PRT will be equal to what? Angle TRS. So this is given that these two angles are what? Bisected. Okay, now what we have to prove? So to prove, what you have to prove, that angle QTR will be equal to half of angle QPR. Okay, so proof. Okay, so this proof is slightly difficult than the rest of the remaining question. All the question in this exercise 6.3 are very easy, but this question there are slight few steps are there, okay. So first step, you see, I will consider this triangle, okay, this triangle. So let me simplify the diagram for you at first. Say I will consider only this triangle PQR, and over here it is S. Say I am considering about only this triangle, okay. So try to try to analyze the diagram analyze the figure in this diagram only. It is not always good to simplify the diagram, okay? So try to directly find in this diagram. But just for your understanding, I have drawn another diagram. Say I will consider only this triangle, okay? You think over here, this triangle, angle PQR, sorry, triangle PQR. Now in this triangle, this is the exterior angle. Again you see in the main diagram, in this triangle PQR, this is the exterior angle, isn't it? This is the exterior angle. So what is the name of the exterior angle? Angle PRS. Angle PRS. So angle PRS will be equal to what? Now this angle is what? This angle is adjacent angle. So I cannot consider the adjacent angle. This angle will be equal to this angle plus this angle, isn't it? Exterior angle of a triangle is equal to the sum of the remote interior angles. This angle you cannot take because this is what? Adjacent angle. So this exterior angle will be equal to what? This angle plus this angle, isn't it? So first you understand by this diagram, then you try to understand the same thing in this complete diagram, okay? So this is the exterior angle and this will be equal to this angle plus this angle. So this thing now we will going to write. Now in triangle PQR, angle PRS will be equal to angle QPR plus angle what? PQR. Okay, plus angle what? PQR. Done? Okay. So now you see in this two proof section, you see angle QTR is there. Okay, we have no angle QTR over here. Then what we have? Half of angle QPR is there, isn't it? Half of angle QPR. This is QPR. And what is there with QPR? 1/2 it is there. So we will multiply what? 1/2. So we have to bring a what? Half. Then only it will match with our proof. Understood? Since with angle QPR, half is there. So we will also have to bring what? 1/2. So if you have to bring a half, then in left hand side also you have to multiply by half. In right hand side also you have to multiply by half. So which implies half of angle PRS will be equal to, multiply directly half with all of them, half of angle QPR plus half of angle PQR. Done? So this part we have got half of angle QPR. So now comes the main part, okay, which implies half of angle PRS. Half of angle PRS. You see this PRS is what? Bisected, isn't it? Like this it is bisected or not? This one you see? Over here T is there. This PRS, angle PRS, it is bisected. This angle is equal to this angle, isn't it? You see over here this angle is equal to this angle, we have written over here. So what will be half of angle PRS? Now half of angle PRS, I can write this angle also, isn't it? What will be half of 60 degree? 30, 30. So I can write 30 this one also. I can write 30 this one also. Means half of angle PRS, I can write this one also. I can write this one also. But what I will write? Take the inside angle, okay? Take the inside one, not the outside one. Inside one. So which angle is the inside one? This one. Means inside that slanting triangle. You go to inside that slanting triangle, okay? Inside this one. This angle I will take, okay? Not the outside one. So what is the name of this angle? This angle PRT. Okay. So half of angle PRS, I will write what? Angle PRT, which is equal to, now half of angle QPR. Which one is QPR? QPR. Is this angle divided? You see half of angle QPR. So QPR is complete. QPR, this angle, it is not divided. So half of angle QPR will remain as half of angle QPR only. That's why in proof also it is what? Half of angle QPR. You cannot break this one. So half of angle what? QPR plus. Next line. Half of angle what? PQR. Now you see in the diagram what will be half of angle PQR. Okay. So see, PQR is also bisected, isn't it? This PQR, angle PQR, this is also what? Bisected, isn't it? See in this diagram, this is also bisected, isn't it? This angle is equal to what? This angle, and the bisector meets where? The bisector meets in this portion at T, at this point T. So this angle is equal to this angle. Now which angle I will take? This one or this one? Again, inside angle. Inside which angle? This slanting triangle is there, na? So you take the inside one. Okay. So this one is outside that slanting triangle. So you take the inside one. This angle I will take. Inside this triangle. Inside this triangle. Okay. This slanting triangle. Inside this slanting triangle, you have to take the angle. This one. So in place of half of angle PQR, I will take this angle. This angle. That is what? Angle TQR. This name TQR. So in place of half of angle PQR, I will write what? Angle TQR. Okay. Done. Question is not completed yet, but first part done. Okay. Say I will give this as what? Equation 1. Okay. First part done. Again, let me break the diagram for you. Okay, this question is slightly long. So one more step is there. Then we will do from 1 and 2 and we will get the answer. Now, at first I have considered this triangle, isn't it? PQR, and then I have used the word exterior angle property. Now I will consider this slanting triangle, and again I will use the exterior angle property. See, again I am simplifying the diagram. So this one over here is Q, over here it is R, and over here it is S. Now I will consider this triangle, not this one, this triangle. So what is the exterior angle? This one is the exterior angle, okay? This one is the exterior angle. So this angle will be equal to what? This angle plus this angle, isn't it? This angle, simple exterior angle property. Okay, over here you write in bracket exterior angle, okay? I forgot to write exterior angle, you write like this one. Again say, again in triangle TQR, this one, this angle, exterior angle, angle TRS will be equal to what? Angle, this plus this, that is angle TQR plus angle what? QTR plus angle QTR. The reason you write, okay? In the previous one, so you write the reason in the previous triangle. Exterior angle of a triangle. Exterior angle of a triangle. Done. Reason you write. Now you see angle TRS. Which one is angle TRS? So in this diagram nothing more is there. So again if I draw this part, so this part afterwards I will draw. So you see this angle is equal to what? This angle is equal to this angle. In this diagram if you see, this angle TRS is equal to what? Angle this, isn't it? Because it is bisected. So in place of angle TRS, I can write what? Angle PRT. This one. Okay. In place of this angle, now this angle is equal to this angle. You see in this diagram, this angle, this TRS is equal to this angle, bisected, isn't it? So in place of angle TRS, I will write what? Angle PRT. Angle PRT, which is equal to, now next angle is what? Angle TQR. Now TQR is also equal to this angle, but I will not write that one. Why? Because TQR is already inside the slanting triangle. See, in place of angle TRS, I have written angle PRT. Why? Because angle TRS is outside the slanting triangle. Okay, I need the inside angle one. So in place of angle TRS, I have written this angle, angle PRT. Done. Then angle TQR, this angle is also equal to this angle, but I will not write this angle. Why? Because this angle is already inside the slanting triangle. So I will keep angle TQR as it is, plus angle QTR, this angle you can do nothing, so keep it as it is, again angle QTR. Give this as what? Equation 2. Done. Question almost done. Only one or two line left. Now you see equation 1 and equation 2. You see angle PRT is equal to this. Angle PRT is equal to this. Left hand side and left hand side of 1 and 2 is what? Same. So from 1 and 2 what I can say, that right hand side and right hand side will also be same. So now from 1 and 2, from 1 and 2 what I can say, that if the left hand side part of 1 and the left hand side part of 2, if the left hand side part of 1 and left hand side part of 2 is same, then the right hand side part of 1, that is what? What is the right hand side part of 1? Half of angle QPR plus angle TQR will be equal to, so the right hand side part of 1 will be equal to the right hand side part of 2, that is angle TQR plus angle QTR. Done. One more line and this question is finished. So you see both side angle TQR will get cancelled. What is remaining? Half of angle QPR will be equal to angle QTR, and this is your proof. And with this chapter 6 completed. So this question is slightly difficult or different than the remaining question of this exercise. If you have still any doubt regarding why this angle is equal to this angle, or why I have written in place of this angle that angle, why I have used half, any kind of doubt regarding this question or any question from this exercise or from this chapter, you can ask. Overall this chapter today it is completed. You practice the examples. In example, if you can't solve any question, answers are already given on this, but still if you don't understand any of the point, then you can ask, okay, that this example I was not able to do. So rather than that, this chapter is completed, and now we will start our next chapter, that is chapter 7. So you have already got your new syllabus, right? In your new syllabus, chapter 7 it is reduced to 7.1, 7.2 and 7.3, and the remaining exercise has been what? Excluded. So once you go through your syllabus, which exercise or which chapter has been cancelled. I think so chapter 5 has been totally cancelled. It is removed, and from chapter 7 I think so only 7.1, 7.2 and 7.3 is there. Okay, so let us start then chapter 7. You go through the examples. Okay, you go through the examples, and if you have any doubt you can ask. So triangles, chapter 7. Is what? Triangles. In this chapter already triangles you have got in class 8 also. So types of triangle you have already got basically 6 types. 3 types by with respect to sides, and 3 types with respect to angles. Okay, so all are necessary. Okay, in first exercise especially the angles, regarding angles whatever triangles are there, that is necessary, and the remaining exercises regarding sides also, that is also necessary. Okay, you must know the types of triangle, that what happens in isosceles, okay, what happens in equilateral triangle. So those type of questions will be there. Your one triangle they will name as isosceles triangle. So by just reading that line you have to understand, okay, this is equal, these are equal in my triangle. Okay, so those are necessary. Again, I am just once going through that 6 type of triangles. With respect to sides, they are scalene triangle, isosceles triangle and equilateral triangle. Okay, scalene triangle, those triangles in which no sides are equal. Isosceles triangle, 2 sides are equal, and equilateral triangle, in the name only it is there, equal, that is all sides are equal. So scalene, no sides; isosceles, 2 sides; equilateral, 3 sides. Okay, then with respect to angle, it is the most easiest one: acute angle triangle, right angle triangle and obtuse angle triangle. Okay, done. So now what we are going to discuss is what? Congruence of triangle. Our topic is what? Our topic is congruence. Congruence of triangles. Simple way, if you need to know what is congruence, congruence means equal, fully equal. And when you say equal, say this this is equal. If I say this is equal, now single it will not be equal. If I say this is equal, then with respect to this I have to bring another marker. Then only I can say that this marker is equal to this marker. If you say equal or if you compare something, then you will always need minimum two things. Okay. So same thing, when we will say congruence of triangles, that means we need two triangles over here. Then only we can say that this triangle is congruent to this triangle. Congruent means same or equal, exactly same. If I say two triangles are congruent, that means that two triangles are exactly same. Shape, size, everything is same. That is only congruence. Just you think that they are same. Okay, exactly same. So it is denoted by the symbol, this one. In the book you will get the symbol. This is the symbol of what? Congruence. So like this we will write. Say one example. Say triangle ABC is congruent to triangle what? PQR. So this is how we denote congruence. Okay, means what? That this triangle ABC, and say this is triangle ABC and this is triangle PQR. ABC PQR means what? If I write that triangle ABC is congruent to triangle PQR, then it means that these two triangles are exactly same. Shape, size, area, everything same. Okay, everything is same. BC is equal to QR. Like this, everything will be same. Side will be same, angle will be same, everything will be same. So that is congruence. Now in this chapter, we have to prove the triangles congruent, and we have to know that what are the property based on which we will say that the two triangles are congruent. So there are several properties. There are four properties are there. By using that four properties, we will say that whether the triangles are congruent or not. Okay. So first property, okay. Say one only. So the first property is side property. Side. In short, we say this is what? SSS. Side. Okay. Okay, you cannot forget anything that you have learned in chapter 6. Okay, that alternate angle, corresponding angle, vertically opposite angle, everything will come over here. Okay, now this thing will not left you anymore. Chapter 6 gone, that means that chapter 6 I will forget, not like that. Okay, whatever you have learned now, all the things will be necessary in each and every chapters. Okay, in the remaining chapters. So everything is necessary. Okay, vertically, alternate, those all things will come over here. As soon as if you see a question where there will be written parallel lines, again you have to assume what? That somewhere alternate angles are there. Okay, straight lines if you see, somewhere vertically opposite angles are there. Okay, like that. So okay, first property is what? Side property. Okay, first I will write the name of the properties. Second property is what? Side angle and what? Side property. That is SAS. In short we write. Now one very important point is there, what? That the angle must be between the sides. That the angle must be between the sides. Understood? This angle must be between the sides. Step by step we will see what are these properties. Then third property is what? Angle, side, and then what? Angle. Angle, side, angle. ASA. Angle, side, angle. In this property, it is not compulsory that your side should be in the middle. Side may not be in the middle also. Why it is that? Again, when we will discuss this property, then we will understand. Okay. So angle, side can stay in between also, or there is one branch of this property. Say that one we will say what? Say angle, side may not be in between also. Side will stay at the corner also. Okay, no problem. Between two angles, side if it is there, then okay, angle, side, angle. Even if it is not there, then also okay. Only we will write what? Angle, side. In place of ASA, we will write AS. That much only. But it is okay. But in this second property, angle must be in between, or else your property will not satisfy. Okay, angle must be in between. Okay, so this is the third property. Fourth property is what? R. Okay, I'm writing first. RIGHT. Right angle hypotenuse side. Right angle hypotenuse side. So right angle we say as R, hypotenuse as H, and side by your side. So this property name is what? RHS. Now there is a confusion is there between this property and this property. Slight confusing is there. Okay. Why you see? See, right angle is the angle. Okay, this is the angle. Hypotenuse is what? Hypotenuse is the side only. Hypotenuse is the side of the triangle. If anyone has forgotten what is hypotenuse, so this is hypotenuse. So this is a right angle triangle. Right angle triangle means what? One angle has to be 90 degree. That means only right angle. So the side opposite to the right angle. So which will be its opposite side? This angle is touching this side. This angle is touching this side also. So they are not opposite sides. They are what? They are adjacent side. This angle is touching this side and touching this side. So they are its adjacent side. So the opposite side will be what? The hypotenuse. The opposite side of right angle is what? This is your hypotenuse. So hypotenuse has to stay. Okay, it is compulsory. And hypotenuse is the opposite side of the right angle, and it is the longest side of the triangle. Okay, of that right angle. So okay, what I am saying is that right angle is an angle. Hypotenuse is a side. It is a side only. It is a side of the triangle only. And side is also a side only. So what I am saying is that angle, side, side means what you see? Side, angle, side. Two sides are there. One angle is there. Two sides are there and one angle is there. Over here also, two sides are there and one angle is there. So there is a confusing in this. Okay. So that I will discuss when I will show you SAS and RHS. Briefly when I will show you each and every property. Then I will say the difference in this between. Okay. When it will be SAS, when it will be RHS. Some of you may think that the difference is what? That the difference is right angle. If it is right angle, then it will be RHS. Absolutely wrong. Okay. Absolutely wrong. It may stay right angle also and it may become SAS also. Okay. Right means 90 degree will stay, but then also it may become what? SAS. Understood? So there is slight confusing. Okay. So right angle does not mean that it will always be RHS. It may be SAS also. Okay, yes, but if right angle is not there, then 100% it cannot be RHS. 100% RHS it cannot become. For RHS, right angle is compulsory. For RHS, right angle is compulsory. But in SAS, this angle can be in right angle also, or acute angle also, obtuse angle also, anything. Understood? So directly by looking right angle, you cannot say that it will be RHS only. It can be SAS also. But okay, when we will discuss, then we will look into that deeply. Okay. Now you see one thing. These are the four properties by which we will prove that the triangles are congruent or not. Okay. Nothing more than that. In this complete chapter, only this property will revolve. Yes, but everything will stay alternate angle, corresponding angles, vertically opposite angles, and whatever you have learned, all will stay. Okay. And your imagination, your looking into the diagram, that is again very important. You have to look the diagram, you have to separate the triangle, then you have to see which side or which angle is equal to what, like that you have to see. Okay, so one more thing, have you have noticed or not, I will say. So you see side is there, three sides are there, one property is there, but there is no property with angle. You will not get a property like that in congruence. Yes, you will get that property in class 10, but not in congruence. In similarity you will get. In congruence, angle is not there. Okay. Three sides you will get. Means what I am saying, that side must be compulsory. Without side, you cannot say that your triangles are congruence. Either you say three side, very good, definitely 100% your triangle is congruence. Or you say about two sides, then also perfect, no problem. Or you at least say one side. You have to say at least one side. You cannot say angle. Like that property is not there. Even in RHS, two sides are there. That is side and hypotenuse is also a side. So one thing you can write as a note, you can write for congruence of two triangles, side is compulsory. This you remember, okay? You will get that property angle, but in class 10 in similarity and congruence. What is the difference, that we will discuss in class 10. Over here similarity is not necessary, only congruence you will learn at first. For congruence, side is compulsory. Okay, in our next class we will discuss each and every property step by step, and then we will start our exercise. Okay, and again, if you have any doubt regarding chapter 6, so this though you have simply started, now you write the properties. Tomorrow step by step we will discuss and the next class. But in chapter 6, if you have any doubt regarding any examples also, you can say examples you practice by yourself. Any doubt in the examples, you just say that this page number and your example number you give. Example number also you can give, that is also fine. And then I will discuss that example in the class itself. Okay, so that's all for today's class. Thank you.